When we talk about trigonometric functions, we refer to f at x, which is equal to the first trig ratio, which is sine x. Then the second one, let's have g at x, which is equal to cos x. The third one can be given as h at x, which is equal to just tan x. So these are the mother functions for trig ratios. These are the mother functions. We once spoke about sine x, cos x, and tan x. These are the trig ratios, but now they can also represent some functions. Now, what do we know on sine, cos, and tan as a function? Now, when we talk about sine x, we really need to know that we are going to be talking about what we call the period of this function, and as it is like that, it is going to be equal to 360 degrees. This is the period of sine. So then the period of cos, it is equal to 360 as well. So it finishes its revolution at 360. So the period of tan is equal to 180. So that's what is different from sine to other trig functions. Now let's get into the amplitude in a sine function. So the amplitude here, amplitude is gonna be just equal to 1. So we are going to discuss later about the amplitude, and of course is also equal to 1 then, and tan, now tan doesn't have the amplitude, so we don't have the amplitude undefined. So the amplitude is undefined there. So let's then come to the range of this function, the range of sine function. The range, it range around sine x, range around 1, then between -1 and 1. So it really doesn't go beyond this range. Otherwise, cos also does the same thing. So we have 1, then we have -1. So this is the range of this one until there is an effect in the perimeters that we are going to be discussing later on. So then tan doesn't have the range. So the range is from -infinity to +infinity. So it is an element of all real numbers from -infinity to +infinity, and the range we are talking about the function itself. So which means we are having y, which means it's an element from -infinity to +infinity. So this is the range of tan graph. Now what are we going to be talking about? Let's then find or effect some perimeters here. So in this one, let's have this function. We have a, then sine x. So having this a, this is the first effect that I want us to talk about. This a does affect the amplitude of the graph. It affects the amplitude of the graph. The amplitude becomes affected as the change of a, as the a changes. Amplitude, which means we are having the amplitude there, and the amplitude is always going to be modulus a. What do I mean by that? A is always positive, so a is always greater than 0. So even if you have negative sine theta, so if you are having this one, you just know that okay, you just have -1, but now having -1, it is always going to give you the positive value. So we just say whatever value that is there, it is always going to give us the positive value of a. So that is a is negative, but the amplitude is just gonna be positive 2. So that is what makes A different from the amplitude. A can be any value, but amplitude is always the positive that value of A. So that means if you are having f at x being equal to 3 sine x, which means this 3 is going to be your amplitude of this graph. So what is the amplitude of this graph? The amplitude of this graph is just going to be this 3. So what is going to be the amplitude of this graph over there? The amplitude of this graph is always going to be the in front value of this trig ratio. So this is the amplitude. So the amplitude is just half. Then what is the amplitude of this graph? So we really don't have the amplitude. It's just a matter of stretching the graph into a vertical direction. It really doesn't affect the amplitude or none whatever, because we really don't have the amplitude for tan. Otherwise the graph becomes straighter, stretched to become more straighter to the vertical axis. So what we have spoken about, the coefficient of A, it does the same thing to the graph of cos as well. So this A is the positive amplitude of this cos graph. So whatever value of that A is, it is always going to give you the amplitude of that graph. So if you are having cos 7x, no matter what number is added there, then therefore your amplitude is just going to be 7. Otherwise, even if the 7 is negative, but the amplitude is always going to be positive 7 units, because amplitude is a distance from the constant line to the turning point of the graph. Now let's try to find another effect. Let's have f at x is equal to, let's have sine b x. We are having this one now. If someone can ask you what is the amplitude of this graph, the amplitude of this graph, you have to look for what is the value of A there. What is the value of A? The value of A is 1. So the amplitude is still just equal to 1. But now, what is the effect of this value B now? Because B was not there from the beginning. So the value of B, it affects only the period of the graph. Now, what is the period of this graph of f? So if someone can ask you about the period of sine graph or the period of cosine graph. So we can also have this graph over there. We have bx. So what does this b affect? How does it affect the period? So b, sine b or cos b, to calculate the period of it, you always say 360 degrees divided by whatever value of b, whatever coefficient of the angle is there. So it's going to give you the period of that specific graph. So even here, the period is always going to be found the same way. What is this value? You divide by it so that you simplify to get the exact period of the graph. Now, for example, if you are having this graph of f, we are having now, we have 3 sine 2x. So let's say you are having this graph. Then you happen to be asked what is the amplitude. Amplitude is just going to be 3. Then what about the period? The period is going to be 360. You just put 360 divided by whatever value that multiplies the value of the angle there. So divided by 2. So the period of this f at x is going to be equal to 180, because 360 divided by 2 is 180 degrees. which means this tree really doesn't affect the period. It affects the what? The amplitude. The amplitude of this graph, amplitude is equal to 3. This 3 affects the amplitude, this 2 affects the period of the graph. So you don't have to confuse the two. Now let's have this graph. We are having g at x here. When you have g at x here, let's have 1/2. Then we have cos, then 3x. Now we are having that one. So now someone is asking, what is the amplitude? What is the amplitude? The amplitude is equal to what is in front of the trig ratio, which is half. The amplitude is half. Now, what is the period? The period is going to be 360 divided by whatever value of b. Remember, the position of b is always in front of that angle, So whatever number that is there, you must know that this is just the value of b. So now, what is the period of this graph? The period of this graph is going to be 360 divided by just 3. So you will get 360 divided by 3 is just going to be 120 degrees. So you can see that this number over there, it affects the period of this graph. Now let's just do this one. Let's say h at x is equal to sine 1/2 x. So if someone can ask you what is the period of this graph, the period of this graph, or the idea is to just 360 divided by the value of b. This is still the value of b, so divided by half. So but it's really not equal to 180. Instead, it's 360 times 2/1, because if you change the division of division, you change it to multiplication, then therefore the numerator becomes the denominator and the denominator becomes the numerator, just that way. Otherwise, you can just say 360 divided by 0.5, you will then get 720. This is 720. 360 times 2 is really equal to 720. So this is going to be a period of this graph. It's going to finish its first revolution, its first cycle, go 720. So this is what we have. So you can find the period of any graph provided that you are given something out. Now let's have this graph f at x, which is equal to sine, let's say 2 into 1/2 x, then plus 15. So let's say you are having this one and someone asks you about the period of this graph. What do you do if you figure out something out there? What is the period of this graph? The period of this graph, you really have to first simplify this one, because this 2 is just a common factor of the whole binomial. Let's just simplify it. So what are we having? We have 2 times half, which is just going to be 1, which is going to be 1x, then 2 times 15, which is just going to be 30. So you can see that this 30 doesn't really have to affect your period. It is just the angle being added that is going to be explained later what it does to this trig ratio. So now you can see that in front of this one you have just 1, so which means the period of this, after you have simplified this can be given as this, then the period is going to be equal to 360 divided by what multiplies the angle there is just 1. So the period is just 360. So it is wise to be able to simplify first before you conclude that, okay, will I divide by half or no? This 2 has an effect to this binomial. So I have to first distribute this 2 to get what really the coefficient of that angle. So this is what we have. Now we can even continue to ask ourselves about what is the period of this graph. Let's say we are having 6 into, let's say we are having x over 3, then plus, let's say plus 3 degrees. So we are having that one. Now, what is the period of this graph? I just want to specify this idea of period, because people, they used to misunderstand these things. Now we are having, let's just first try to simplify this one, because you can see that this 6 seems to be the coefficient, the common factor of this binomial. So let's just distribute it to make, or to simplify the f at x. So f at x can also look like 6, then 6 times 3 of that. So 6 divided by 3 is just 2. So you have 2x. Then 6 times 3 is just going to be 18. So this is what we have. So indeed, the period, we just look at the end, what you call the coefficient of the angle. The coefficient of the angle is really equal to just 2. So which means the period is going to be 360 divided by that 2. So which is going to be 180 degrees. So that is what we have. So if we can look for other parameters now, like for example, if we are having g at x, which is equal to, like for example, we are having 2 sine x plus 4. If you are having that 4, well, of course, this 4, it shifts the graph vertically upwards. So if you are adding 4, you are adding 4 to the whole function, which means it's going to affect the y values. So y values are going to go up 4 units upwards. So hence this 4 is going to affect the range, because range, you only concentrate on y values, so it does affect the range. So before anything else, we knew that when you are having g at x equal to just sine x, the range of this graph is y, or you can say g at x was between 1 and -1. So this was your range. So that means if you are having this new g at x with 2 sine x, right? So you can see now that the g at x is multiplied by 2. Can you see that this is our new g, this is our old g at x, this is our new g at x now, which means this g at x is multiplied by 2. So the idea is to say, okay, the new range now is going to be, we just multiply this by 2, multiply this by 2, then you get the range minus 2, then you have just 2. So the range is going to be affected by this one. When you increase this one, it affects the range. It does affect the amplitude. We spoke about that as well. But we are saying this one also, it affects the amplitude, not the amplitude, but the range of the graph, because it shifts the graph vertically upwards. All the points along the y-axis, they shift vertically up. So that means if you are having this graph, let's say we have g of x is equal to 2 sine x. We spoke about the range of this graph, that it's gonna looks like that one. But now if you are looking for a new range when you are having +4, that means the range, you have to add 4 here, you have to add 4 here, you have to add 4 there. So that means your new range, the range of this is gonna be, remember you have g at x, you have g at x, which is less or greater than, then 4 minus 2, which is just gonna be 2, then 4 plus 2, which is just going to be 6. So the new range is going to be that. So you need to know where does these numbers, these perimeters, that are added to these trig functions affects the perimeters. The perimeters, the range, the amplitude, the period, all those things. So you need to know which number that affects what, so that you don't get confused when there are questions that comes thereafter. Now let's come to this one. Let's have h at x is equal to, let's have 3 sine, then let's have x plus 20. Now you are having this one, and of course we still know that, all right, we still know that we are having this 3, which is our amplitude. Our amplitude is 3, and our period is equal to what? Is equal to 360 divided by what is in front of this x, which is just 1. So the period is just 360. So what does this 20 does? It shifts the graph into left and right, into a horizontal direction. So it affects the domain, the domain of the graph. It shifts the graph left and right, not upwards or downwards. Only this value of q that has an effect on the y value of x. That is why this value of q over there, it affects the range of the graph. If you add q there, the range will be affected. If you subtract q, the range will be affected. Otherwise, the rest of other things, except this one, because this one also have the tendency of changing the range, because now the range before these two being added, the range of this function is -3, then y, then 3. So this is the graph along the vertical axis. It is going to be open this way. So which means this value of a there and the value of q there, those are the values that really affect the range of the graph. So unfortunately we haven't come to the position of drawing the graph, so that we see what happens when we really put these effects to specific functions. Otherwise, we are just going to look for some things that are going to show us practically this acting in front of us. So on that note, let's just have tan. What happens to tan? So when you have tan x, the period of tan x, we spoke about the period of this graph. The period of tan x is 180. Otherwise, the period of tan 2x, this is the b that we spoke about. The period is gonna be 180 divided by whatever value of q there. So this is what we have. So the period of this graph is going to be just 90. So this is how the period is changed. Now we must know or remember that our tan graph is the only graph that has some asymptotes. The asymptotes is where this tan graph is not found. So it is the line that this tan graph will never touch. So it really doesn't touch, this one really doesn't touch when x is equal to 90 degrees. And also when x is equal to -90. It depends on the interval that is given. Where do you want your tan along the x-axis? Otherwise, this one, to make 90 there, it's whereby x is equal to 45. When x is equal to 45 to this graph, you have 45 times 2, it gives you 90, and tan 90 is undefined. So the equations of asymptotes, the first one is 45, and of course x is equal to -45 can act as the as one of the solutions for the equations of asymptote. So having that being said, let me just leave you for now. Otherwise, we are going to do practical examples for the rest of this chapter, trigonometric functions. Thank you for watching. See you right in the next video. Bye.